Let's talk about uniform distribution. And again, it's that pretty kind of rectangle looking box. So again, uniform distribution is a continuous probability distribution and occurs with events that are equally likely to occur. The one thing I always think about with uniform distribution, say that I want to toss a 6-sided dice 1,000,000 times, the probability to get 1, 2, 3, 4, 5, and 6 will make this kind of distribution. It's the same occurrence that it'll likely occur. So here, if you can see, this distribution goes from 2 to 8.75, and I'm looking at the purple from 3 to 6. So the notation for uniform distribution is the distribution approximates U with A comma B, where A is the lowest value and B is the highest value. So the probability distribution function of f of x is 1 over b minus a, for a is less than or equal to x is less than or equal to b. So the y-axis ending point is what we're looking at for the 1 over b minus a. Okay, so let's look at one. So the mean is a plus b over 2, and the standard deviation is the square root of b minus a squared over 12. Okay. So the amount of time in minutes that a person must wait for a bus is uniformly distributed between 0 and 15 minutes inclusively. What is the probability that a person has to wait fewer than 12.5 minutes? On average, how long must a person wait? Really, you're going to find the mean and the standard deviation, and 90% of the time a person must wait, the time a person must wait falls between what value? Okay, so let's do the first one. So the amount of time that a person must wait for a bus is uniform between 0 and 15 minutes. Okay, so let X be the number of minutes a person is waiting for the bus. A is 0 and B is 15. Remember, A's got to be the lowest value, B's got to be the highest value. So I can write it this way: the distribution approximates U between 0, 15. Write the probability distribution function. So f of x equals 1 over 15, because it's 1 over 15 minus 0. For 0 is less than or equal to x is less than or equal to, I need to put this because that's not correct, 15. Okay. Fixing my typo. Okay, so there's my typo. So that's what that means. That's how you write it. Okay, so the amount of time in minutes that the person must wait for the bus is uniformly distributed between 0 and 15. What's the probability a person must wait fewer than 12.5 minutes? So I wrote it that P, the probability is X is less than 12.15 equals 12.5 minus 0, because they could wait potentially 0 minutes. Remember, I've got to go to 0 on this one because it started at 0 right here. And it's 1 over 15 because that's that. Remember that 1 over 15 minus 0. So I get 0.883. The probability that a person waits fewer than 12.5 minutes is 0.833. And here's the picture of that, okay? Here's the 1 over 15, 0 to 15, and I want to know this area in purple. So that was 0.833. All right, so let's do another one. How do I get the mean? Again, 15 plus 0 divided by 2 equals 7.5 minutes. The standard deviation is, I fill it in, where 15 minus 0 squared over 12 equals 4.3. That 12 is a constant, is always going to be that, okay? So the amount of time in minutes that a person must wait for a bus is uniformly distributed. 90% of the time a person must wait falls below what value? Okay, remember, all we're doing here, these are base times height ones. Okay, so I don't know my K in this one, which is kind of crazy because I want to know where it falls. So I'm going to put 0.90 because, again, that's the area or the percentage equals K. I don't know what this K is going to be, 1 divided by 15. So if I take the 15 to the other side, I get 0.90 times 15 equals 13.5. 90% of the time, the person must wait at most 13.5 minutes. That's how you do that one. Why? Because I didn't know what this K was, because I wanted to know how much time will it be for 90% of the time. Okay, let's do another example. Suppose the time it takes a 9-year-old to eat a donut is between 0.5 and 4 minutes inclusively. Let X be the time in minutes it takes a 9-year-old child to eat a donut. So then at the distribution is uniform 0.5, 4. All right. The probability that a randomly selected 9-year-old eats a donut is at least 2 minutes. Okay, so remember, at least is the same as 2 in this one. So it's 4 minus 2 times 1 divided by 3.5 equals 0.5714. And remember, the 3.5 is 4 minus 0.5 equals 3.5. So the probability is almost like 57% that they'll eat it in at least 2 minutes. Okay, and that's how you do that one.